Here's an image of our Class 1 lever. In the Class 1 lever system, the fulcrum is located in the center. And on one side of the fulcrum, you will find the effort. And on the other side of the fulcrum, you will find the load. We tested two variables in our lever system. The first variable that we tested was the location of the effort on the lever arm. As we move the lever arm away from the fulcrum, we recorded the amount of force it took to lift the load. We started at 2.5 centimeters, then moved to 5, 10, 15, 20, and 25. We were moving away from the fulcrum. As we lifted the load, we recorded the amount of force. The force is recorded in newtons. I can see that when it was at 2.5 centimeters, it was 7 newtons. And when it was at 5 centimeters, it was 6.1. And when it was at 10 centimeters, it was 3.1. And 15 centimeters was 2.2. 20 centimeters was 1.0. And I can see that those numbers are decreasing as I get further from the fulcrum. We took 7 groups of data and we recorded it on a scatter plot. We took data from 7 groups and they're designated each a different symbol to recognize where they're placed in the scatter plot. In scatter plots, we do not connect the dots like line graphs. Instead, we try to recognize a trend. The trends that I recognize here is that the dots are scattered, although they follow a trend of decreasing. And when I create the trend line, I kind of create it in the center of the dots, but I do not connect dots. So now I can see a trend that those dots are following. They're decreasing as we move along the x-axis. Now that I have the trend line, I want to identify the summary statement. And this summary statement will be a statement that analyzes this information and helps us transfer and use this information whenever we use Class 1 levers. So the first thing that I look at is the title. The title is going to show us or tell us the variable that we're testing. The variable that we were testing was the position of the effort. And when I look at the x-axis, it tells me that one thing we were doing was moving the effort along the lever, and we were moving it further away from the fulcrum. 0 was where the fulcrum was located, and as we moved it to 5, 10, 15, 20, 25, we were moving it further from the fulcrum. So my summary statement is going to start with those two pieces of information. The position of the effort moved further from the fulcrum. And I'm going to end my statement using the information from the y-axis, which tells me the amount of force, and I can see the amount of force decreased as I moved away from the fulcrum. So as the effort moved further from the fulcrum, the amount of force needed decreased. Now I can use this information anytime I use class 1 levers. If I am unable to move the load and need to decrease the amount of force, I know I can move the effort further from the fulcrum. Now in test B, the fulcrum remained in the center, but the effort was now a controlled variable and stayed at 10 centimeters. The load is what we tested. We moved the position of the load away from the fulcrum. 2.5, 5, 10, 15, 20, and 25. Each time you recorded the amount of force needed to lift the load, and you recorded this in newtons. I can see that at 2.5 I recorded 1.1 newtons, and as I moved away from the fulcrum, I can see that those numbers, or the amount of force needed, increased. 1.1 to 2.4, 3.2, 4.1, all the way up to 7.1. As we look at the scatter plot for our second test, testing the position of the load, we took data from 7 different groups. We can see that the trend line increases. The amount of force increases. So let's use all of our information on our graph to write a summary statement. Start by looking at the title, which identifies the variable that we tested, the position of the load. And notice that the x-axis tells us the distance from the fulcrum in centimeters. And as we move along the x-axis, we can see that the amount of centimeters increased, which tells us that the load was moving further from the fulcrum. So we'll start our statement with that information. When the load moves further from the fulcrum, and finish with information from our y-axis. The amount of force increases. Now we have a summary statement that will guide us anytime that we use a class 1 lever. So we can apply this knowledge anytime we use a class 1 lever. The most common class 1 lever that we are familiar with is a teeter-totter. So let's say you are on one end of the teeter-totter, and you have a friend on the other end who is larger or weighs more, and you're struggling to lift them. We know now that it is because when the load is at the end of or furthest from the fulcrum on the end, it's going to require more force to lift it. So if we have our friend move closer to the fulcrum, then we will use less force to be able to lift them. Now I would like you to take a look at your work from last week. First, be sure that you have the trend lines accurate. follow the flow of the dots. Next, check your summary statement and be sure that you incorporated all of the information from the graph, starting with the variable that was tested. Add the information from the x-axis and the y-axis to make a full statement. If you have words that are circled within your statement, those are the key words that you need to check and correct to be sure that they accurately explain the information in the graphs.